So what we want to talk about then is exposure control. And when we talk about exposure control, even though adjusting things for exposure is primarily for controlling the amount of light, we've now learned that by making adjustments to aperture and shutter, it's going to have effects on other things as well. We're going to talk about those other things as well. But first and foremost, whenever you're doing photography, and remember the definition of photography is to paint with light. So in photography, what's first and foremost? It is light. Because by the way, your photo can be perfectly focused. You can have exactly the right lens. You can have exactly the right color. And guess what? If you take a photo that's extremely underexposed, it's just going to be black. Anybody have any photos that were just black last week? Yeah. Can't see anything, right? So you can see the first and foremost variable to consider whenever taking photos is light. One variable that needs to be in your list, by the way, that I didn't think you mentioned was color. Color needs to be in that. One of the questions on your quiz, if you guys remember, was the job of a police photographer is to take what? Accurate photos. And what's a big part of accurate photography? Color. Color. All right, there are two primary ways to control exposure. Shutter speed and aperture. All right, shutter speed and aperture. That's what we're going to focus on for the next little while. Shutter speed and aperture. Now, in a camera, doesn't matter what kind of camera it is. Doesn't matter if it's a TLR camera, a view camera, a rangefinder camera, an SLR camera. Remember, we said that all cameras have four basic parts, right? There's four basic parts, so remember our lens, shutter, aperture, and recording medium. We're going to be focusing primarily in our discussion on the shutter and the aperture. Right. So two ways to control exposure, very likely test question on our midterm exam coming up is what are the two ways to control exposure? Or rather, let me say that these are the two primary ways to control exposure. Because actually there are other ways that we could control exposure besides these main two. These are the main two. The main two ways to control exposure are controlling how long the shutter is open by altering the shutter speed, or by controlling how far open or closed the aperture is. And we do that by manipulating something called the f-stop. F-stop, that number, references how far open or how far closed the aperture is. So quite often you'll hear me just use the term f-stop to refer to aperture, or you should know that when I talk about aperture, what I'm talking about is the f-stop. You'll hear them used interchangeably, synonymously. There are other ways to control exposure, though. One of the ways I mentioned a little bit before is ISO. ISO stands for International Standards Organization number. International Standards Organization number, just abbreviated ISO number. That number used to refer to, and still actually does, refer to the sensitivity of the film you were using. Right, now we're using digital cameras primarily for this class, but when we used to shoot with film, when you would purchase film for your camera, you could purchase not only different size films, the most common of course being 35 millimeter, but there were larger or smaller films. There's 110 film, which is smaller. There was 4x5 film, which is bigger. But not only would you have to choose between different film sizes, largely dependent upon the camera you had, but you would also choose a different film speed. And film speed referred to how quickly the chemical reaction would take place on the surface of the film, which would ultimately lead to the image being burned into the emulsion layer of the film. In film, and by the way, the film stuff, I'm not going to touch on any of the film stuff, but just so you know, the recording medium of film, the way it worked was film was coated in silver crystals, so small pieces of silver. And when light would hit these silver crystals in the emulsion, it would cause a chemical change to those silver crystals, to the point where those silver crystals turned opaque, meaning they turned dark, turned black. And so when you took a photo, what you would get on a piece of film was a negative. What was white would turn black on the film, what was black would be white. Right? Now, how quickly that chemical change took place was largely dependent upon the size of the silver crystals in the emulsion. The larger the silver crystals, the faster they would react. Which would mean if you had film that had larger silver crystals in the emulsion layer, then it would change quicker. Which means when you took your photos, you didn't need to leave the shutter open as long. So it was what we called fast film. And so we needed a way to know whether or not the film was fast or slow. And so that's where these ISO numbers come from. The larger the ISO number for the film, the faster it was. The most common ISOs you see for film now, if you were to go to the store, a film store to purchase film, 100, 200, 400, 800, 1600, 125, 60, those are the most common. Most common by and far are the 100, 200, 400. So when you buy your film right on the box, it would say either 100, 200, or 400. That would tell you then, okay, this is faster film, 400 speed film would be faster, which would be good for taking photos at night or indoors or at a sporting event where you have fast movement, because it would mean that the film would react quicker. So I could use faster shutter speeds. Slower film, very good because it had higher resolution, but it required you to use slower shutter speeds. On digital cameras, we don't use film, but we still have ISO, because the microchip in the back of your digital camera, the CCD or CMOS sensor, you can actually increase or decrease its sensitivity by changing the ISO. What you're doing is basically you're increasing or decreasing the current running across the sensor, which is how you basically read how bright or dark the image is. The problem with ISO, though, now, in terms of its effect on exposure, if you ramp up the ISO, what you do then is you allow yourself to take photos in darker environments. So it does affect exposure. You don't have to expose the recording medium as long because the recording medium is more sensitive to light. So are there benefits to ramping up ISO? 100%. Especially in crime scene situations, because think about it, in crime scene situations, it's typically what in terms of light? It's usually dark, nighttime, right? Or think about taking photos, you know, in the shed of someone's backyard where they've got the body buried. Darker environments. So it would be good to have a recording medium that was more sensitive to light when I'm taking my photos in those darker environments. But remember I said before, there's a drawback. Every time you make a decision, there's positive and negative consequences. A positive consequence of ramping up your ISO is it doesn't require as much light. Can anyone tell me what the negative consequence of ISO is? What is it, Gabe? Yeah, you start to lose resolution. Joanna mentioned graining. In a film image, when you would blow it up, when you would make an enlargement, you actually would start to see the little silver crystals. The image would actually start to appear, and the term we would use is graining. Why graining? You'd actually be able to see the silver grains in the emulsion showing up in the picture. In a digital image, when you blow it up, it becomes what we call noisy. In either case, what do we lose? We lose something called resolution. And resolution has everything to do with image quality. If you have low resolution, you lose image quality. So that's why, technically, ISO is a way to affect exposure, but it's not a good one, because you lose image quality if you ramp up ISO. In crime scene photography, do you think we want high resolution or low resolution? Very high. We want high image quality. So are we likely to ramp up our ISO to high numbers like 800? No, we're going to use ISOs around 100 or maybe even lower if we can. So again, there are other ways to control exposure besides shutter and aperture. ISO is an example of one. Another one is simply turn the lights on. Like add more light. That's a way to control exposure, right? If I just simply add more light, but you don't always have that option. Question.
So last week when we were outside taking pictures,
yep.
It's dark. We could have turned the ISO up.
You could have.
And then that would compensate.
That's
somewhat
correct.
For
That's correct. So let's say your shutter speeds are just too slow and you need to use faster shutter speeds. Well, the problem with using faster shutter speeds is now you start to lose light because the shutter's opening and closing so quickly. Okay, so if I'm losing light because I'm opening and closing the shutter quickly, I run the risk then of having my photo being too dark. Well, if I increase the sensitivity of the microchip, that's okay because it reacts quicker, so I don't need as much light. So yes, if I ramp the ISO up, that would allow me to use a faster shutter speed. But again, the problem then becomes, though, I would get a properly exposed photo, meaning it wouldn't be too dark, but I would have lost resolution because I ramped the ISO up. Does that make sense?
Yeah, but if you say, for example, it was set on 100
Yep.
and you went to 200,
Uh-huh.
would that be significant?
Not significant.
But maybe the 800 it wouldn't.
800 definitely significant. And you don't always notice a loss of resolution until you start to blow things up. You guys ever taken a photo off the internet, for example? Maybe you copied a photo and you thought, that's a really cool photo. But when you copied it, it was just this little teeny tiny photo. And then when you stretched it to make like your screensaver on your computer, suddenly it gets pixelated. That's because that image is low resolution to begin with. You don't really always notice issues of resolution until you start looking at small details or until you start blowing things up. Let me actually give you a definition of resolution. Please write this in your notes. Resolution, and this is, by the way, this is not the dictionary definition. If you look it up in, the Webster's dictionary, it's going to say something a little different. I'm going to give you what I call a working definition. A working definition of resolution is the ability to visually distinguish between two features. So the ability to visually distinguish between two features. Or you could also say the ability to visually separate two features. The ability to visually distinguish between two features. Or to visually separate two features. In other words, you can tell them apart. Let me demonstrate that for you real quick. Take a marker here. And on the board here, I'm going to draw two dots. Okay? All right, you guys see the two dots there? Okay. And that's because they're fairly large and they're fairly spread apart. So you have no problem resolving these two dots. You can visually distinguish between the two. What do you think is going to happen, though, when those dots get smaller and closer together? Well, let's see. I'm going to make them now just a little smaller, a little closer together. Okay. Now, depending upon where you are in the room, Joanna's here pretty close. PJ, you're pretty close. You can probably still see two dots, right? As you get, though, to the back of the room, if I were to ask you to, hey, bet $1 million if there's really two dots there or not, you might be a little bit less willing, right? Because what happens as you get farther away is suddenly your brain starts to merge them together. You might still be able to see two dots, but again, what if I make them a little bit smaller and a little bit closer together, right? What ends up happening is eventually you lose resolution. That's what happens with the digital camera. If features get too small and too close together, the camera just merges them, right? And you can stretch the image all you want, it's not going to separate them. What you end up getting, when you take a digital image and you enlarge it, but it doesn't get any clearer, we call that empty magnification. Meaning you're just magnifying nothing. Right? How would you increase the resolution of a digital camera? What do you think? By making the pixels on the sensor smaller. Right? The way a digital camera works is, remember, a digital camera has that microchip in there. It's called a CCD or a CMOS, depending upon the technology in your camera. And basically, it's a grid. It looks a lot like a solar panel that might be on your roof. And if you look at solar panels, they're divided into these grids. Right? It's basically a circuit, almost like a circuit board. Right? And so an image gets projected, so the light goes through the lens, it's focused, and an image of whatever you're taking a picture of gets focused on this sensor. Let's say I'm taking a picture of something really basic. Looks like a smiley face, right? Something just like this, right? So we have, it's projected onto the sensor, right? Now, as long as the features fall on separate, and by the way, each of these boxes is a pixel, a picture element. As long as each feature falls on a separate picture element, the camera, the sensor can tell them apart because they fall on different sections of the grid. What happens, though, if those two features fall on the same pixel? What do you think the sensor does? It merges them into one. You've lost resolution. How would you increase the resolution of that sensor? make the pixels smaller. If each of the pixels was half as large, meaning you put more of them on the sensor, now it falls on separate pixels. It can now differentiate them. That's why when you buy a digital camera, the larger the number of pixels on the sensor, ultimately the better the resolution of the image because it's able to separate all those small details. How many pixels are on those sensors? Think about it. When you buy a camera, this digital camera. Anybody buy a digital camera in the last little while? What was the resolution of your CCD or your sensor? Do you remember? First of all, usually what units are they expressed in? Megapixels, right? So we're talking about megapixels. Mega, by the way, is a metric prefix. It means million. So when you talk about a 10 megapixel sensor, you're talking about a sensor that's divided into a grid that has 10 million little boxes. That's amazing. That's an engineering miracle, right? That's why digital cameras cost so much money. All right. So if you want to increase, I'll get to your question in a second, Dale. If you want to increase then the sensitivity, sorry, not the sensitivity rather, but the resolution of a digital camera, then you would increase the number of pixels by making them small. Because the sensor itself doesn't get bigger. The sensor stays the same size. So how do you make the pixels? How do you make more pixels? You make them smaller. So think about it, you guys. The sensor inside of your digital camera, the SLR camera, is about 1 inch by 1 inch square. So that means on that little 1 inch by 1 inch square, there is a grid divided into millions of small little boxes. That's pretty amazing. Question, Dale.
Well, so when you buy the camera, is it a set amount of pixels?
Yes. The sensor, it has a set amount, depending upon what camera or model you buy.
Okay, so can you take that set amount and use less of what you have?
Yes. So when you take photos, for example, very rarely when we take photos, the average person, you and I, when we take photos, very rarely do we take our photos in what's called an uncompressed format, meaning when we take photos, all 10 million bits of information are recorded. Normally when we take a photo, that information becomes compressed into a file format, a compression file format. The most common one that you and I look at when we look at images are JPEGs. JPEG is a compressed file format. And so it doesn't have 10 million pieces of information. It actually takes sections of the CCD that all seem to have the same color and the same tone, and then it creates one big, huge block for that whole section, instead of having 10 million little blocks of that same color. It's called a compression format. And your camera, if you wanted to take a photo that truly was uncompressed, truly unadulterated, you had information for all 10 million little boxes, that file format is what we call RAW, instead of JPEG, or there are other compression formats, JPEG being the most common.
How do you save it as well?
On your camera, if you go into your features, your menu options in the camera, there's a way for you to change the settings so that you can change it to RAW. Almost all digital cameras will let you do that. The file sizes are huge though. Like, you know, your memory card, you put your memory card in your camera, you save the pictures. If you take your photos in RAW on a 1 gigabyte card, you might get 100 photos on there. If you're using a 1 gigabyte card and you're taking JPEGs, you can put thousands of photos on it because it's compressed.